Hello geometry students and welcome back. This video we will talk about the converse of the Pythagorean theorem. Now as we know, and as we learned about in a previous video, the Pythagorean theorem says that if we have a right triangle, then a squared plus b squared equals c squared. That is, the sum of the squares of the legs is equal to the square of the hypotenuse. The converse of the Pythagorean theorem says, well, what if we have these three numbers and we want to know if they make a right triangle or not? Or, well, if a squared plus b squared equals c squared, then we get a right triangle. But what if a squared plus b squared does not make c squared? Can we use that information that we have to tell us what type of triangle it is? And we actually can. The converse of the Pythagorean theorem tells us just that. Now, it's important to note when we're talking about this that it's easiest to remember this if we put it in terms of c squared coming first. So we have some rules right here that state if c squared is less than a squared plus b squared, then we have an acute triangle. So if c squared is less than meaning smaller than, so that goes with acute. And if c squared is equal to a squared plus b squared, then we get a right triangle, which is what we were working on before. And if c squared is greater than a squared plus b squared, then the triangle that we get is an obtuse triangle. And this c squared equals a squared plus b squared is the same thing we did in the last video, just before we said a squared plus b squared equals c squared. And this way, when we put c squared is less than, that's acute, c squared is equal, that's right, and c squared is greater than is obtuse. Remember that c will always represent the longest side of our triangle. If it's a right triangle, then that is a hypotenuse. But even if we don't know, then c would always be our biggest number. Okay, so let's try a few problems. Given these three lengths, determine if a triangle can be formed. If so, classify the triangle as acute, right, or obtuse. So first we want to make sure that we actually get a triangle. When we were learning about triangle basics, we learned that triangle inequality says that when you add up the two smallest sides, that number has to be bigger than the third side. So first we want to make sure we actually get a triangle. So for this one right here, actually, you know what I'm going to do? I'm going to highlight our biggest number each time. This one over here, you might need to use a calculator to tell what this number is. We'll talk about that when we get to this one. So first we want to check to make sure when we add up the two smaller sides, it's bigger than that. When we add up 4 plus 9, that's 13. That's bigger than 12. So this does make a triangle. Good. Now let's explore c squared and a squared plus b squared. So we want to compare c squared to a squared plus b squared. So c squared, that's 12 squared. We want to compare that to, I'm leaving this a blank right here. In the end, I'm going to put in a less than, greater than, or equal to. A squared is 4 squared plus 9 squared. Well, when we do 12 squared, we get 144. When we do 4 squared plus 9 squared, that gives us 16 plus 81, which is 97. And c squared is greater than a squared plus b squared. So this is an obtuse triangle. For problem number 2, again, we want to make sure when we add up the two smaller sides, it is bigger than that third side. 7 plus 7 is 14. That is bigger than 8, so it does make a triangle. Now let's compare 8 squared with 7 squared plus 7 squared. When we calculate 8 squared, we get 64. 7 squared plus 7 squared, that's 49 plus 49 makes 98. 64 is less than 98, so this is an acute triangle. Number 3, when we add up the two smaller numbers, 5 plus 17, we get 22, and that is not bigger than 23, so these numbers do not make a triangle. So we don't need to try to figure out if it's acute, right, or obtuse, because it's not a triangle. All right, and our last example here, 4 plus 4 square roots of 3 and 8. Well, we might want to check our calculator just to make sure. What is 4 times the square root of 3? And if you put that in your calculator, you'll find out that that's approximately 6.8. So when we add up 4 plus that 4 square roots of 3, we get about 10.8. It is bigger than 8, so good. Now let's compare 8 squared with 4 squared plus 4 square roots of 3 squared. So when we do 8 squared, again we get 64, and 4 squared is 16, but 4 times the square root of 3 squared might be a little bit trickier for us to do. Now we can certainly do that with algebra, and when we do that, then we would get, I'm going to note algebra down here, and then I'm going to also use Desmos. When we do 4 times the square root of 3 squared, we're really squaring each part. So we're using 4 squared and the square root of 3 squared. 4 squared is 16. The square root of 3 squared is 3, and 16 times 3 makes 48. But let's explore how to do that on Desmos, just to be sure we know how to do that. If we wanted to square 4 times the square root of 3, then we would want to put this in parentheses. 4 square root of 3. Go over parentheses, and then when we square that, we get 48. So if you're having any trouble with the algebra, feel free to use Desmos. So this gives us 16 plus 48, and when we add up 16 and 48, we get 64 on the right side, 64 on the left side. C squared equals a squared plus b squared, so this makes a right triangle. So what you should do now, I've got 6 problems right here. Take a few moments and try these on your own. I'm going to pause the video. I'm going to work them out, and when you start, you should pause the video, work them out, and then when you unpause the video, you will see the answers to each of these with them worked out as well. Okay? Okay, so picking up where we had left off before, you can see the answers here. For number 1, 9 squared is bigger than 4 squared plus 7 squared. And I meant to do this before, but I'm going to, I think it's a good idea to always highlight the biggest number so that we always make sure which one we're using for C. And when we do that for number 1, C squared is greater than A squared plus B squared, so we have an obtuse triangle. And number 2, C squared is equal to A squared plus B squared. And again, I recommend using Desmos for this if you're not sure, but this comes out to be 75 plus 25, which makes 100. So we have a right triangle. Number 3. On number 3, when we add up the 2 smaller sides, it is not greater than the third side, so number 3 doesn't even make a triangle. Number 4, our C squared is equal to our A squared plus B squared, so we have a right triangle. Number 5, our C squared is less than A squared plus B squared, so we have an acute triangle. And number 6, our C squared is greater than A squared plus B squared, and so we have an obtuse triangle. So there you have it. That is how to use the 3 sides of a triangle to determine whether we have a right triangle, acute triangle, or obtuse triangle, or whether they even make a triangle at all. Okay? Bye-bye.